So this video is on Chapter 8, Synthetic Division, worksheet number 2. So on this one, I'm going to set it up in a different way. I'm going to do it more in a table format. So again, just like I was doing the other day, we are trying to figure out what makes each of these 0. So I'm really going 0 is equal to x to the third plus 4x squared, minus 11x minus 30. And we are looking at our P and our Q. So our Q is going to be what multiplies to 1, and my Q is going to be what multiplies to 30. So I'm going to have a lot more choices, but these ones are all going to be integer choices because my lead is a 1. So I'm just going to list my P over Q's here. So P over Q. All my P's are things that multiply to 30, things that divide into 30. I'm just going to put the plus minus in front of the whole entire thing. So I'm going to have a positive, negative 1, 2, 3, 5, 6, 10, 15, and 30. So 1 times 30, 2 times 15, 3 times 10, 5 times 6. That's everything that would multiply to 30. All over plus or minus 1. And again, since all of these are going to be over 1, I really have integers. So it's going to be a positive, negative. I'm just going to put the plus minus in front of everything, but all of them are positive, negative. 1, 2, 3, 5, 6, 10, 15, 30. So I have 1, 2, 3, 4, 5, 6, 7, 8, 16 because of the negatives also, choices. Now what I'm going to do is I'm going to do it in a column form more because I might not get it on the first try. So I'm making a table like this. Okay. I've got a 1, 4, negative 11, and a negative 30. The one thing I want to pay attention to is my constant here at the end. If I was to put 0 in for all my x's, when I have 0 for my x's, I would get a negative 30. Basically, my y-intercept is negative 30. So I am 30 below the x-axis for this graph. I like to kind of think about that. I see that right here. That's just something to kind of think about as I'm doing this. So let me try a 1. And what I'm going to do is I'm going to bring my 1 down. And I'm going to be doing my adding in my head. And I'm just going to put the result here. So I brought my lead down, which is 1. 1 times 1 is 1. I add it to 4, and I get a 5. 5 times 1 is 5. I add it to a negative 11, and I get a negative 6. Negative 6 times 1 is negative 6. I add it to a negative 30, and I get a negative 36. So I'm going down, okay? But hopefully I'll start coming back up. Let's just try 2. Okay, bring down my 1 again. 1 times 2 is 2. Add it to the 4. I get 6. 6 times 2 is 12. I add it to a negative 11. I get a 1. 1 times 2 is 2. I add it to negative 30. I get a negative 28. So you see I'm coming back up to the x-axis, getting closer. 3, bring it down. So 1 times 3 is 3. I add it to 4. I get a 7. 7 times 3 is 21. I add it to a negative 11, and I get a 10. 10 times 3 is 30, and I add it to a negative 30, and I get a 0. So right now, I just found, oops, sorry, I thought I was in highlight. I just found a 0. Okay, so one of my zeros is going to be x equal 3. Okay, that's one of my zeros. So I was starting with a degree 3. So that means this depressed polynomial is now a degree 2. So I'm going to write x squared plus 7x plus 10 and set that equal to 0 and solve. And I can factor that. When I factor that, I'm going to get an x plus 5 and an x plus 2. So I'm going to get a negative 5 and a negative 2. So I had x equal 3, -5, -2. Those are my three solutions. Remember, for a degree 3, I should get 3 solutions. On number 2. So again, I'm focusing on my P, which is a 1, and my Q, which is an 8. Okay. So again, since my P is 1, when I do my P over Q's, I'm going to get all integers. So again, I'm just going to put a plus minus here. So positive, -1, 2, 4, and 8. That's what multiplies to get 8 over positive, -1. So I'm going to have a positive, -1, 2, 4, and 8. Those are the numbers I'm going to try. So again, I'm going to do it in a column form. 1, 1, -10, 8. My 0 is 8. So right now I'm 8 above the x-axis. Okay, let's try 1 and see what happens. So I'm going to bring down my lead here, which is 1. 1 times 1 is 1. I add it to 1. I get 2. 2 times 1 is 2. I add it to -10, and I get a -8. -8 times 1 is -8. I add that to 8. I get 0. So I lucked out and happened to get it on the first try. So this right here is giving me a solution. So I have x equal 1. That's going to be a solution. I'm going to take this depressed polynomial, which is now an x squared plus 2x minus 8, set it equal to 0 and solve. So I'm going to get an x plus 4, x minus 2 equals 0. So I'm going to get a -4 and a +2. So x equal -4 and x equal +2. And those are my 3 solutions for my degree 3 polynomial. Number 3. Okay. This time it's a degree 4, so I'm going to get 4 solutions. I'm going to have to take this down to a 3 and then down to a 2. So the one nice thing is, again, my lead, my P's, or my Q's, sorry, are going to be 1. And my P's, I have a lot of them because it's a 48. So I have a lot of choices, a lot of factors is 48. So my P over Q. Plus or minus. Now for 48, 1 goes into it, 2 goes into it, 3, 4 goes into 48, 5 does not, 6 goes into it, 8 times. So you can see 6 and 8. So 4 and 12, 3 and 16, 2 and 24, and then 1 and 48. And again, it's all over plus or minus 1. Now, when I put them all over a positive or -1, again, I get all integers. And again, all of them are going to be positive, negative, but I'm just going to list them 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48, and the negatives. Okay, so I'm going to do a table. 1, -1, -16, 4, and 48. So I'm a 48 above. I'm gonna try 1, bring it down. Okay, 1 times 1 is 1. I add it, I get 0. 0 times 1 is 0. I add it, I get a -16. -16 times 1 is a -16. I add it, I get a -12. -12 times 1 is a -12. I add it, I end up with a 36. Okay, so I'm getting closer to the x-axis. Sometimes you might want to jump ahead, but you want to make sure you don't jump too far and you jump over a 0. Okay. So I'm gonna do 2. Bring down my 1. 1 times 2 is 2. I add it, I get a 1. 1 times 2 is 2. I add it, I get a -14. Negative 14 times 2 is a negative 28. I add it, I get a negative 24. And negative 24 times 2 is a negative 48. And I add it and I got a 0. So again, even though I was 36 above, I want to just continue kind of in order here just to kind of see what was happening, because sometimes you can jump over a 0. And I would have missed a 0 if I would have skipped ahead. So I got 1, 0. Okay. So I know I have x equal 2. Now I'm going to take this depressed one, which is now a degree 3. And so I'm going to have 1, let me do it in a different color. I'm going to have 1, 1, negative 14, and a negative 24. Now for this 0, I'm at negative 24. Also, this is a negative 24. It's no longer 48. So that means I am not going to be doing anything that does not go to 24. So 48 will not be one of them. 16 will not be one of them. Let's see. 1 goes in, 2 goes in, 3 goes in, 4, 6, 8, 12, 24. I think those are the only ones I can cross out. I'm also going to understand that since positive 1 did not work here, it's not going to work again. Okay. Now 2 worked before, it could work again. So we could try it. I'll just try it and see what happens. Bring down a 1. So 1 times 2 is 2. I add it, I get a 3. 3 times 2 is 6. I add it, I get a negative 8. Negative 8 times 2 is 16. I end up getting a negative 8. Okay, I'm getting closer. Let's say I try a 3. Bring down my 1. 1 times 3 is 3. I add it, I get a 4. 4 times 3 is 12. I add it, I get a negative 2. Negative 2 times 3 is a negative 6. I add it, let's see, it was a negative 6. So I get a negative 18. Let me just double check this one. This was a negative 16, so negative 8. Okay. And let's say I try 4. And I'm just going to pause for a second because I did make a mistake and I want to point it out to you, and I do apologize. So when I was doing this here, I did 2 times negative 8 is a negative 16. It's a negative 16, not a positive. I was thinking positive 16 in my head. It is a negative 16. So this is not a negative 8. So I have a negative 24 minus 16, which, make sure I have it. There you go. Which is a negative 40. And I think I did the same thing here. So 1 times 3 is 3, add it, I get a 4. 4 times 3 is 12, add it, I get a negative 2. Negative 2 times 3 is a negative 6, add it, I get a negative 30. So I am getting closer to 0 here. Okay, just want to make that correction. So I'm going to try a 4 now. So 1 times 4 is 4, I add it, I get a 5. 5 times 4 is 20. I add it, I get a 6. 6 times 4 is 24. I add it to a negative 24 and I get a 0. So I did find a second 0 here. So I had the x equal 2 from before, and now I have an x equal 4. And now this is going to be a degree 2, x squared plus 5x plus 6 equals 0. Factor that, I get an x plus 3, x plus 2 equals 0. So I get a negative 3 and a negative 2. So x equal negative 3 and x equal negative 2. And those are our 4 solutions. Number 4. Okay, so on this one, less to try, so that's a little nicer here. My Q is still going to be positive, -1. My P's, I'm going to have positive, -1, and 5. So let me just write out again my P over Q's, positive and -1 and 5 over plus minus 1. So that's going to give me just a positive -1 and a positive -5. Those are the 4 I'm going to try. So let's say I try 1. Let's say I've got a 1, 4, -4, 4, and a -5. For 0, I am at -5, so I'm 5 below. Let me try 1. I'm going to bring down my first number, which is 1. 1 times 1 is 1. I add, I get a 5. 5 times 1 is 5. I add, I get a 1. 1 times 1 is 1. I add, I get a 5. 5 times 1 is 5. I add, I get a 0. Okay, so I have a 0 here. So I do have x equal 1 as a solution. I am now going to take 1, 5, 1, 5 and do a new synthetic division. What I'm going to say here, notice that my P is still 5, so that's not going to change these. But notice that these are all positive. If I do a positive number, nothing's going to cancel out because none of these are negative to help reduce. So I'm not going to try the positive 5, and it definitely will not be a positive 1. So I need to try my negatives, either -1 or -5. I'm going to start with a -1 and then see what happens with that. So 1 times -1 is a 4. 4 times, so okay, I should say 1 times -1 is a -1 plus 5 is 4. 4 times -4 is a -4 plus 1 is a -3. -3 times -1 is a 3. Add it, I get an 8. So I'm thinking it's got to be the 5. Bring down my 1. Okay, 1 times 5 is 5. Oh, sorry, -5. I apologize. 1 times -5 is -5. Add it, I get 0. 0 times -5 is 0. Add, I get 1. 1 times -5 is a -5. I add, I get 0. So now I have my second 0. And so I have x is equal to -5. Now I'm going to take x squared plus 1 equals 0 and solve. Now, when I do this, I am going to get a -1. When I take the square root of this, I'm going to have a positive or negative I. So I get imaginary answers here. So x equals I and x equals -I. We always get conjugates with complex numbers. And those are my 4 solutions. It's only going to cross the x-axis twice, though, because these imaginary solutions make it 0, but these will not be x-intercepts. On number 5, okay, I'm going to have more choices here because my lead is a 2, so I'm going to have fractions possibly, and my P there is going to be a 4, so plus or minus 1, plus or minus 2, plus or minus 4. So P over Q. Okay, so my P is a 4, so it's going to be plus or minus 1, 2, or 4 over my Q is a 2, which is going to be plus or minus 1 or 2. So if I put all of these, I'm just going to put a plus or minus in front of all of them. I'm going to take 1 over 1 and 2 over 1 and 4 over 1. Then I'm going to take those same 3 numbers and put them over 2. 1 over 2 is a half. 2 over 2 is a 1, which I already have. 4 over 2 is a 2, which I already have. So I have these choices. Okay, so let me go and draw my table. So 2, 1, 7, 4, -4. Bring down your first number, which is a 2. So right now at 0, I'm at -4. So let's just try a 1. 1 times 2 is 2. I add it, I get a 3. 3 times 1 is 3. I add it, I get a 10. 10 times 1 is 10. I add it, I get a 14. 14 times 1 is 14. I add it, I get a 10. So at this point, I was starting with a positive. I got no positive, I got only positive back. So what that means is this is an upper bound. So I am not going to do a +2 or a +4. The polynomial at this point, since it's degree 4, positive degree 4, it's going to be having n behaviors like this. I'm on the up part. Okay, it's not going to come back down. So I'm going to go the other direction. So let's say I try -1. Okay, again, bring down that first number, bring down the 2. 2 times -1 is -2. I add it to 1 and I get a -1. -1 times -1 is 1. I add it to 7, I get 8. 8 times -1 is a -8. I add it with 4, I get a -4. A -4 times a -1 is a 4. I add it to -4 and I found a 0. So I have a 0 here. So one of my answers is going to be x equal -1. So now I'm going to take my 2, my -1, my 8, my -4, and continue. This is now a degree 3. Now, -1 could work again. So sometimes I try it just to see what happens. Bring down the 2. 2 times -1 is -2. I add it, I get a -3. -3 times -1 is a 3. I add it, I get an 11. 11 times -1 is a -11. I add it with a -4. So I had -11, I add with a -4, I get a -15. Let me just double check. 2 times 1, -2, add it, -3. Multiply this a +3, get an 11. -11, I get -15. So what happens here is when I'm dealing with a negative and I get alternating signs, then this is going to be a lower bound. So that means I'm not going to try the -2. I'm not going to try -4. They're not going to work. So I'm thinking it has to be the 1/2. Or I should say, well, it could be a positive 1/2 or it could be a -1/2 because 1 was an upper bound. Okay. And the one thing I will say is this -4 was my 0. And at 1, so at 0, I was below the x-axis. I was down at -4. And at 1, I was above at 10. So I have a 0 somewhere in between because if I am below and then I end up above, I have to touch. So I'm going to try that positive 1/2 and let's see what happens. Bring down my 2. 2 times 1/2 is 1. I add it, I get 0. 0 times 1/2 is 0. I add it, I get 8. 8 times 1/2 is 4. I add it, I get 0. So 1/2 was a solution. I have to highlight and not purple here. Okay, so I ended up with x equal 1/2 also as a solution. Now I have 2x squared plus 8 equals 0. I'm going to divide everything by 2 and get it down to x squared plus 4 equals 0. I'm going to minus 4 from both sides and get a -4. I'm going to get imaginary answers here. I'm going to square root and get a plus or minus 2i. So I have 2 x-intercepts, and then I'm going to have these 2 roots, which are not going to end up being x-intercept. 2 and its reciprocal, not reciprocal, sorry, conjugate 2i. These are my 4 solutions.